Morning and welcome to day 8 of distance learning. We're going to go over our day 8 math today, and it's starting with where it looks like we're going to be comparing numbers. Again, we've been focusing on that place value of numbers the last couple of weeks, and it looks like it's going to carry over onto today. So we're going to be using the less than, greater than, or equal to fill in the blank when we are comparing two numbers. And it's important to remember when we're comparing two numbers, we need to start with the hundreds, compare those numbers. If they're the same, we're going to move next door, and so on and so on. So looking at number 1, it looks like we are comparing 732, and we are comparing that to 861. Let's go ahead and start looking at the hundreds column, and we have a 7 and we have an 8. Because they are different numbers, we are able to compare them based off of the difference of the hundreds column, and that can tell us that 732 is less than 861, because remember, we're reading them, we read from left to right. That's how we are going to base the sign off of. So 732 is less than 861. Always check your work by making sure that the alligator, if you remember that video you watched, the alligator mouth is opening to the biggest number. Okay, moving on to number 2. Here they have given us a number in standard form, and we are comparing that to a number in expanded form. The easiest way to do that is to turn our number from expanded form and go ahead and turn that into standard form for us. It just makes it easier to compare. So here we have 500 plus 40 plus 2. We know there are 500s, there are 4 tens, and there are 2 ones. So we know we are comparing 542, and we are comparing that to 421. Again, we are going to start with comparing the number in the hundreds column. Here we have a 5, here we have a 4. No need to even move on to the tens, because we are able to compare these based on just the value of the digit in the hundreds column. We know that the 5 is greater than 4, so that tells us that 542 is greater than 421. Moving on, we have a couple more of these. Number 3, we're going to be comparing 912, and again, they gave us another number in expanded form. We are going to turn the number in expanded form. We're going to go ahead and show that number in standard form and then compare the two. So here we have 900 plus 10 plus 2. We know there are 900s, there is 1 10, and there are 2 ones. So we are going to be comparing 912 to 912. Starting again with the hundreds column, we have a 9. We are comparing that to a 9. That is the same, so we're going to move on to the tens. We have a 1. We also have a 1 here, so we're going to move on to the ones. We have a 2. Moving on to the ones here, that is also a 2, which is telling us that is exactly the same number. They have the same value, and when something has the same value, a mathematical way of saying that is that it is equal to each other. So we know 912 is equal to 912, or 900 plus 10 plus 2. Moving on to number 4, we are going to compare these two numbers. This is very similar to what we did yesterday, where it is the same numbers, they're just mixing them up. So it's important to go by place value, because depending on where that number is in a number, it's going to determine its value. So we're going to focus on the hundreds. Here we have 2. Here we have a 4. We don't even need to move on to the tens column, because we are able to compare this number based on the digit and its value in the hundreds column. We have a 2 and a 4. We know that 2 is less than 4, so that we know 204 is less than 420. Okay, and then we are going to move on. We have a math task for today, and there are 3 parts to this math task, so we will go in order A, B, and C. This task, we are going to be using the digits 2, 5, and 7. Moving on to A, we're going to use all the digits 5, 7, and 2 to create a different 3-digit number. So the 3-digit number it gave us is 257. So in order to do that, we're just going, it's not telling us a specific value. It just wants us to create a different 3-digit number. So we can take these numbers and create whatever, we're going to take these 3 digits and create whatever number we want, as long as we are using all 3 numbers. So I'm going to say 7, a 5, and a 2. I used all 3 digits. It is a different number than 257. So that's how we are going to show it in a different way. Moving on to B, it's asking, what is the greatest number you can make using all of the digits? Okay, so basically what we're going to do, we have 3 digits. We need to place them in order based from greatest to least. If we do that, that's going to give us the largest possible digit we can make with this number. So if we're looking at the 3 numbers, we have 5, 7, and 2. We know that 7 is the greatest value. And then between 5 and 2, 5 is the greatest value. And then moving on, 2 has the least value. So actually the number we made in A is ironically going to be the same number. So using those 3 digits, the greatest number we can make is 752. And because they wanted us to show the greatest number, C is asking us what is the smallest number you can make using all of the digits. So whereas in B we were focusing on which number had the greatest value, now we're going to be looking at the numbers that have the least value. So I'm going to go ahead and add a text box here. And we're going to look for, using those 3 digits, which one has the least value. Comparing the 3 numbers, we know 2 has the least value. And now we're moving from 5 to 7. Which would you rather have, 7 ice creams or 5 ice creams? Now we're focusing on the smaller, so we want to know which one is smaller, 5 or 7. 7 ice creams is greater than 5, so we know the 5 is going to come next. And last is going to be the digit with the greatest value, which is 7. So which is the smallest number you can make using all 3 of the digits? It is 257. Okay, so now we're going to move on to our fluency for today, and our equation is 53 minus 14. If you look, we have a subtraction symbol, which means we are looking for the difference, which means we are going to be taking 14 away from 53. It's asking us to use any strategy. Lining these numbers up based on the place value and using the standard algorithm is a great strategy to use here. So let's go ahead and get started. Remember, we need to focus on the ones column first. We're going to break these apart based on the place value and do it in 2 different steps. So we need to subtract 3 from 4. If you have 3 of something, you cannot take 4 away from that because you do not have enough to give them. So we're going to need to regroup. We need to borrow from next door. So our 5 is going to become a 4. And because we're taking one of the 10s and moving it over to the ones column, the 3 is no longer going to be an option. The 3 is going to become a 13. Let me move this so that you can, okay, perfect. So now we can subtract. Now that we have 13 of something, we have enough to take 4 away. So if we have 13 and we take 4 away, you can put the 4 in your head and count up to 13 on your fingers. So let's go ahead and do that. 4 in your head, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Stop once you get to 13 and you should have 9 fingers held up. That is going to let us know that 13 minus 4 is 9. Now we can go next door to the tens column and subtract. We have a 4 and we need to take away 1. If you have 4 of something and you take 1 of them away, you have 3. So we know that 53 minus 14 is 39. Moving to the next box, it wants us to use models or visuals. Again, the best way to do this is your base 10 block. So as you can see, I've represented 53 with our 10 bars and our 1 blocks. Well, just like in this column, if you have 3 of something, you cannot take 4 away. So we need to swap out a 10 bar for 10. Okay, so we've swapped out that 10 bar and we are going to switch that out for 10 ones, and now we will be able to complete our equation. What we need to do is again, breaking it apart, we need to remove 14 of them. We have 53. Let's count to make sure. We have 10, 20, 30, 40. We know this is 10. That is 50. And 1, 2, 3. So we have 53. We need to take 14 of them away. So the easiest way to do is take a 10 bar, and then we are going to remove 4 ones. 1, 2, 3, 4. Move those off to the side, and then let's count, and we should have 39. Each of these is worth 10, so we're going to count by tens. 10, 20, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the best way to represent this problem in pictures or models. Writing a story, again, just coming up with that word problem. We have 53 minus 19, so a word problem that represents that. Just an example, you do not have to use mine. You can use whatever you want. These are just to help you. There were 53 cupcakes for the class. 14 students got 1 for behaving. How many cupcakes were left? That is an example of how to write a story to represent an equation. And how do we know our answer is correct? We always use that inverse operation to check, and we know inverse operation means opposite. So if in our equation we were subtracting, we are going to use addition to check our work. So we're going to take the difference, the 39, and we are going to add it to one of our add-ins. I decided we were going to add it to 14. 39 plus 14 equals 53, which equals that second add-in, so we know our work is correct. I hope you guys found this helpful. If you have any questions, please reach out to me. Let me know. I will do my best to help any way I can. I hope you guys are staying safe. I miss you, and we will see you soon. Goodbye.